Hello everyone, today I'm going to show you how we can create a custom shield force like the one you see on screen. I've covered some custom forces before, but those were mainly advection by volume. This one I'm going to set up a custom force. The force itself isn't going to be using any volumes, but we will be using VDBs to adjust some of the positions of the points. It's probably the type of thing that can be set up in a million different ways. Just going to show you one way to do it. We'll start off by creating an interesting emitter. Then afterwards we'll be setting up our shield geometry in SOPs. And in DOPs we'll be setting up our shield force. And we'll also be adjusting the positions based on a volume. And then lastly I'll show you how you can use pop streams to kill points based on how long they've been in a state. Okay, let's get started. Okay, as a base we'll start off in a scene with Paul and Louise test geometries in there. So we have something for scale reference and something to aim at. I'll create a geometry where we're going to build our force, and we can call that shield force. Or a shield effect. Then if we dive inside there, first thing I want to do is create my emitter. And so that's going to be a sphere. But I want to make it a little bit more interesting than that. So let's create some polygon geometry from that. Maybe give it a little bit more resolution. Don't need much. And we're going to scale it down to 0.05. It's fairly small. And let's zoom in on that. And to make it more interesting, I'm going to make 3 copies of the sphere. So for that, I'll get a copy and transform. And then I'll just shift the original sphere off to the side a little bit. Maybe 0.06, something like that. Then I'll make 3 copies, or have there be a total of 3 copies. And then I'm going to rotate each time I copy. And if I divide by 360 and paste that value, see, paste relative references. Now, if I divide 360 by the amount of copies, then I get like a perfect circle in rotations. So you can see if I increase this amount, it's always going to add up to 360, and we get this nice rotation. So I'm just going to use 3 of them because I like the look of that. And I'm going to turn on copy num. That's going to create a primitive attribute for each copy. You can see that over there. It's going from 0 to 2 because we have 3 copies. And I'm going to create a random color base of that for each one of those, and it's a primitive attribute, so I want the class to be primitive. And I can say random based on attribute, and that attribute is called copy num. Now I've got 3 different colors there. And just for later to transfer to the points, I'm going to attribute promote this to point level. And I want to go from primitive to point, and I want to transfer CD, and it can just be first match. Okay, so now we got a nice colored emitter. I want to make this emitter rotate as well, so we'll get a transform. And with this transform, just see what axis, I think in Z. Yes, I want to rotate in Z. I'll use an expression and say add time. and just multiply it by an amount. I'm going to go for 25 right now. And I'm going to hit play. And that's how fast it's spinning. Probably a little bit too slow. I could multiply this value up, but I can change this to multiply at frame as well, and it's going to be a lot quicker. And I'll use that as a starting point instead of at time. Maybe we don't even need to speed it up. Yeah, that looks very quick. Let me just set time to be real time, and yeah, that's more what I want. Okay, so that looks good. I'm also just going to reduce my timeline because I see it's a bit long for what we need. I'll just make it 120 frames and set my FPS to 25. Okay, so now it's rotating. Now we can transform it into place as well. So I'll get a separate transform for that, so I have a different control for the rotation altogether. And with this one, we can move it into place. Let's say it's shooting it from around there. And I'm gonna give it a little bit of animation as well. So let's see, on frame 1, I'll make it 0. Have it over about 8 frames, go up to a value of 1, let him fire for about 50 frames, then maybe have it dissipate for a couple of more frames. I think that's just linear curves for now. We can leave it to that for now, that's fine. We should have that source appearing and disappearing again. And that's going to be our basic animation. From there, I want to source points in these volumes. And by volumes, I mean the whole volume of each geometry. So for that, we get our points from volume. And probably have to reduce the resolution because we are working quite small. Make it 0.02. Now we can see some points there. It's not very many, but it's enough to get started with. And then I also want to transfer that color attribute. And because it's not sourcing on the surface, it won't get that color automatically. So we need an attribute transfer. Just to copy the closest CD value. Like that. And I would like to jitter this as well. And I want the seed to be different every frame, so we'll use that frame again. And set the jitter scale to 1. Now our emission will look something like that. Those are going to be our source points. And I don't want these to be perfectly shaped, so I'm going to add a little bit of noise as well. I'm going to attribute noise. And I'm actually going to apply that noise to the geometry. So I'm just going to jump one level up, stick it in before we convert to points, and it's not the color I want to affect, but the position. And I want it to be 0 centered. And the type of noise we can make, let's go for a value noise, a sparse convolution. This noise doesn't need to be animated because the circle's already animated. But this is way too strong. So I'll make it 0.2. So it's just a little bit of breakup. And I think the element size can be a lot smaller as well. Make that 0.2. Maybe that's still too strong. So 0.05, 0.1. Yeah, I think that's a good value. So play. Yeah, that looks good. And the last thing we're going to need for the emitter is a point velocity. And this is going to control our force. So I'll add a force and I'll just make it +10 in Z. And I'll add just a little bit of curl noise as well. Let's see, let's go a few frames in. I should probably also set this to keep incoming velocity, or actually set value, because I don't actually want to have it try and compute the velocity for the changing points coming in. Yeah, so that's the velocity we get. And this can probably be, keep the value to 1 for now. The swirl size might need to be a little bit smaller. Okay, let's see how that works. We can always adjust it a little bit later. Get a null. This is going to be our emitter. And I'll call it source. Okay, next up we're going to create the shield geometry, but let's just test our emitter by dropping down a pop network. And I'm just going to stick that into the first input, dive inside, and I'll set my source to all points because I already created the points. And I'll jump back to the first frame and hit play. You can see this is what our emitter is looking like. Sourcing is working and our noise looks way too strong. We can adjust those settings a little bit later. Let's set up our shield so that Louise has something to block this force being shot at him. So to do that, I'll get another sphere. And this one, we can make it fairly big. I'll make it 3. And I'll make a poly mesh. And to help myself for a little bit later, I'll have it facing in Z. And we can be fairly generous with the rows and columns. Let's go for something like 120 by 64. I want that to be a semicircle, so I'm going to use a clip sop and just cut that down to size. I want to cut it in Z, not in Y. Then we can move it into position. So take this guy, shift it along over there, and lift it up. Probably want it the same height as what this one is. It doesn't have to be perfect, but it's more or less 1.38. That's 1.28. It's fairly close, somewhere along there. And we can probably move it a little bit forward. Okay, so this is going to be our blocker force. And how are we going to set up that force? You could try and just make a collision and use 0 gravity, and maybe that works if you do shoot the points strongly enough, but it might get stuck on the collision or not slide the way you expect it to. So it's better to create a force if it's something that you want to control. And what I want is a force from the center pointing outwards to all of the edges. Luckily, we can use the distance along geometry node to find out how far all the points are from a certain number point on the geometry. So we want the distance along geometry. And if we give it any point, it'll calculate the distance geometrically on the surface. You can set it to edge as well, but the surface is the one we're interested in. From that point to all the other points. And very conveniently, point 0 is the one right in the center because of the way the circle geometry gets made. So I can set the start point to 0. And let's see if that is visualizing. It's not, but if I middle click, I can visualize distance. Now you can see we get this gradient. This is a scalar, it's not a vector, but it is giving us a distance. And just to show you, if I change this to say 0.1000, get a different looking gradient because 0.1000 is over there. So let's set this back to 0. You can use the measure SOP now to convert scalar values into vectors by getting the gradient of the scalar value. And to do that, I'm going to pick a gradient. I want to get the gradient of distance. And let's see, and this is going to create a new attribute called gradient. So let's visualize that. And it's set to primitive at the moment. I actually just want to get that to be a point. Annoyingly, it's visualizing as a color and not as a vector. How can I change that? Let's just change this and say we want a marker, and the marker should be vector. Okay, that's a bit better to look at, so we can see what's actually happening. Now you can see what we're getting. This is 0.0. We get this vector is perfectly pointing outwards along the geometry from the zip all the way to the end. So what this is doing is it's looking at the point and its neighbors and the distance value between the point and its neighbors and giving us a vector for the direction of maximum change. And this is super useful for a lot of things and a cool way you can convert scalar values to vector values. And this is what we're going to use to drive our force. Okay, now we've got these vectors. The value will change based on that distance, but our distances are fairly similar, so you can see the vectors don't change that much. But I would prefer to try and control them myself. So what we can do with that is just going to drop down a wrangle, and I'm going to create a velocity attribute from this gradient attribute. And I'll create a new vector, and I'll call the vector v, and I'll make that equal to the gradient, but I'll normalize it. And the vector I want to normalize is that gradient. And we can set velocity to equal to v. If I turn that off and we just display the velocity, it looks like it's going the other way because it's trails. That's a bit hard to read. So I'm just going to turn on this one again. And just set our gradient to that value for now, just as a visualization. Set that equal to v. And you can see this is now normalized length. But we've got this distance as well. So we can remap that distance with a ramp if we want as well, and use that to drive the strength of the force. And to do that, we can create a fit node or a fit function and say float dist equals fit add dist, and then this would be 2 channels. Should be channel F. That will be start distance. We'll just say start dist and end dist. And then I'll fit that to 0 and 1. And the reason I'm fitting it to 0 and 1 is because then we can feed that into a ramp afterwards. So then we can say dist equals channel ramp. And with the ramp, we can just call this force ramp. And we want to ramp dist. And then the last thing I want to do is control how strong the force is when the ramp's at the minimum and how strong it is at the maximum. So you can fade it off to 0, but you can also keep that force going if you want. In this case, that is what I want. That's why I want the control for it. So I'm gonna get dist again, and I'm gonna fit that again. And I can make it fit 01 because I already know it's between 0 and 1. I want to fit dist. And then I'll say channel F. I'll call this start force, or it could be near force. Maybe start is better. And then maybe near far was better. I'll go for end. And force. Create all those parameters. We shouldn't be getting any errors, hopefully. Looks like it's working. And now we can just multiply this v value by dist. We can remove this one because it was just for visualization. So now we can see more or less where the start and end is. Let's see, it's about 0.5, like a core area. If you go up to 5, get all the way to there. I like to push up the ramp values really close to each other to kind of see where the end is. Something like that. I'd say it's about from there to there, it's about 5 units. So maybe let's set this to 0.5. Set this down to about 4. And then for the force strength, we can just make it a little bit stronger at the beginning. So let's make it like, let's see. Make it 20 and 10, and the color visualization isn't helping us that much anymore. I'm just going to turn that off. And then there's this ramp as well to control how this force changes along that gradient. Okay, so we can call this shield force. And now let's see, let's create a null for that one as well. Stick it in there, call that shield. And let's plug this into our pop network as well. And let's see if we can make a force out of this. So to do that, I'll get a pop wrangle. and in the popper angle I'll call this shield force. And then on the inputs, I'm going to set the second input to second context geometry, which is the second input of the popnet. So to create a force out of those in DOPs, we'd want to test how close the points get to the input geometry in DOPs, and then sample that velocity value. And I just realized that I forgot something on the setup there. I'm just going to be using near point to sample, and because I'm doing that, I want to have more points to sample so it's a bit more accurate. So I'll get a scatter, plug that in there, and that's gonna copy that velocity attribute. And because we're scattering, we can make a lot more points. It just means that we get nicer points to sample from. And we won't as easily miss any samples. So then in the wrangle in the pop network, we can create an integer attribute called pt, which is going to be our near point, and then use the near point expression. And I want to sample at position. I should just say I want to sample input 1. And then I'll create a channel, which is going to be the search radius, which will be our maximum distance. So any points that are further away from this will ignore this force. I'm just going to create the channel, make it 0.5 for now. Then I'll create an if statement and say if pt not equal to -1, and that just means if a point has been found, then we'll run this code, otherwise do nothing. So now we know the point has a near point. What we want to find there is we want to find the point velocity. So that would be input 1, v at pt. And what we want to set that to is force. So it's v at force. And we want to add to the current force. So that would be plus equals, because we don't want to override any other forces. We just want to add to it. So it'll be like that. I'll change the color as well so we can see when it is in this range. We'll say add CD. So I'll say add CD equals set, and we can set it to something like 0, 1, 1 to get this teal color. And to use later, I'm also going to set up a group to mark the points that have been hit. Just call that point. I'll just create a group, call it hit, and I'd say that's equal to 1. So our force should already be working, but if you remember earlier, our emission wasn't looking that nice. So I'm just going to adjust this a little bit. I'll make it a bit stronger. I'll make it something like 20. And I'll reduce the scale to 0.5, maybe the duration as well. I'll make the swirl size even smaller, like 0.1, so it's like a bit more random. Okay, now moment of truth. Let's see what we get out of this. Gonna hit play. The points blasting out, and you see the colors changing, and the velocities might be adjusting a little bit. Definitely fanning out a bit more, so it's picking up some of that force, but the force that these particles are coming out with is too strong for that force to actually stop it by itself. It's just kind of blasting right through it. So we could adjust the strength of our force but we've already got this at like 20 and 10. But there's one other gotcha to watch out for. So if we go closer to this guy, and let's just visualize this velocity attribute. So it's a bit strong now, so just set it to 2 and 1 so we can see it. Notice one thing, it looks a bit funny at the beginning. You actually get points pointing back inwards. The reason for that is when we calculate this gradient, this very first point gets a gradient value that points back to the center. Because it's 0.0, it's where the gradient starts. So an easy fix is to actually just delete that point before we scatter the points. So I'm just going to go to point selection and get rid of that one. So we'll have a little hole at the center. You can always subdivide more if you want to get rid of that. Just to make sure all our force points are pointing outwards. This will give us a little bit of a nicer result, especially initially. But of course, because we're pushing outwards and it's adding a force, we're still going to get the same problem of the points shooting off into the distance. And let me just show that. So I'll add a pop drag as well. This will help a little bit because we're adding forces. We need something to slow the stuff down as well. You'll see this is probably going to go straight through again. Maybe it looks a little bit nicer. You can see it's dragging now as it goes on, but same problem still exists. So the next trick I have for that is to build a shield geometry as well, to actually stop the points from ever being able to go through this shield area, and that kind of depends on the look you want. You can do this with forces as well, but in this case what I'm going to do is I'm going to take this geometry from there, get a poly extrude, and with this poly extrude, it's going to extrude it outwards like that. That should be big enough. I'll put it back for it. If we don't do that, it's hollow. And I'll convert that to VDB. And we can leave the voxel size to 0.1, that should be fine. I'll create a null for this as well. And this is kind of like a type of collision we're creating, but not exactly. We can call this blocker. And I'll stick this into the third input. Okay, now to make our blocker stop the points, I'm going to dive back into DOPS, and I'll set this one up in a pop-up because I'm sure you guys are tired of all the wrangles. And I'll set the second input of 1 to be the third input context. And we can call this push outside volume. And I don't know, I might have shown this sort of technique before, but it's something you'll see other people use online as well. You probably ran across it before. But what we're going to do is use volume sample. And with volume sample, we're going to test where we are inside that volume. And we also want a volume gradient, which is going to be the vector pushing out of the volume. The sample position is going to be our current position of the points. And for the file node, we can set both of them to second input. And we only have the one volume, so we can keep this to primitive number 0 and just keep it to primitive number. So this will get dist, and this will get the gradient of that, or the volume is called surface, so this will get surface and the gradient of surface. Now I'll normalize that gradient, and it's also pointing in the wrong direction, so I'll negate it. Now we have a normalized value pointing outwards. And I'm gonna multiply that by the distance. What that means is it's just gonna ensure that if the point is, say for example, a distance of 0.5 inside the geometry, it's going to be pushed out in the direction of the gradient by 0.5, so it'll go right back onto the surface of that geometry. I'll get a compare node as well. Because the other thing we need the distance for is we want to test, and we want to test if we're less than 0, because we want to test if we're inside that VDB. Because we only want to apply this if we're inside of it. And luckily with VDB, it gives you an inside and an outside value. So you always know that's something you can test. Now we need an if block. And in the if block, we can just move that over there. And we can compare. And if that is true, we're going to take the position. And we're going to take that value. And we're going to add it to the position. And we're going to give it a new position. So this is a position update. Now let's set our camera and play that and see what happens. See, we get some funny behavior, but it kind of looks like it's working. At some point shooting through, maybe we're just going too quickly. Okay, and the reason we're getting some of these points going through is when we create this VDB, some of the interior voxels are being deactivated as well, because the only active band is the 3 voxels around the surface. So if you full interior, that should help us. So if I play, you can see it's containing all our points now. But our force isn't really behaving the way we would like it to. Because they're not accelerating around this impact as quickly as we want. The reason for that is if we look at the velocities are all wrong. Like it's adjusting outwards very slowly. The reason for that is we're updating this position, but we're not doing anything to the velocity. So if you're doing a position update like this, you also need to recalculate your point velocity. And we can do that using a point velocity node. Or just, I think it's just called pop velocity. So this is going to be a manual velocity update, which I'm going to drive this bell with. And if I just write v in the expression, it's going to be equal to this vector. So by default, I just want to set that equal to v at v. But then if I want to update the velocity, I can say if at, and now we can use some of the pre-built or some of the attributes that we get from the solver. And we want to make sure it has a previous value before we update the velocity, otherwise it's just going to force our velocities to 0. And the attribute we're looking for, maybe I should just show you what we're looking for before writing it. I play. We want to use p previous, and we want to use has p previous. So we want to make sure it has a previous point. So we say at has, I think it was underscore p previous. If that's equal to 1, then we want to update v, and we want to update that by, I think it's take the current position, divide by, or subtract it from the previous position, and the previous one is v at p previous. And then we want to divide that by the time increment, because we're working in seconds. And let's see what that gives us if we hit play now. Still a bit getting stuck in the beginning, but we're getting some proper velocities now, and it is sliding along the surface a bit quicker. So yeah, we're getting there with force. Starting to look a lot more interesting. And that's our velocity fix. We can probably optimize this a bit more by only testing for points that has been affected by the force or has collided with this guy. But this should do us good for now. Okay, before working on the look, the last thing I want to do is set up a timer, and just to test or just to control like when it gets into this state, when do we want to delete some of these points. And we could just set an age attribute on the points and kill them by age, and that would be the simplest possible approach. But in some cases it could be useful to have a timer to know exactly when it started in this state and when it's going to be, or how long you want it to be in that state before it gets deleted or move into a different state. So to do that, I'm going to get a pop stream node. And in pop stream, I can simply say if hit, because that group that I created in there was called hit. If that is true, I want to move this into the stream, and I want to preserve the stream. And just to test that it's working, I'm going to turn off this color and just create a new color. Over the pop color. I just want to test that points are successfully moving into the stream. Just make it some teal color again. Let's hit play. We can see that's working. So now that we're in this state, we can very easily test. We just get a pop angle again, and just want to set up a timer. So create an attribute, and I'm just going to test it in frames. So I'll just say in state plus equals 1, and because we're in a dot network, this is going to keep increasing each frame, and everything that's not in the state is going to default to 0. And we probably don't want all the points to be dying at once, so let's create something to control when the points die randomly. So I'll create a float value and call it seed, and just say that'll be a rand at id plus some extra values times 3. This gives us an interesting random value, and I can fit that, and this be a fit of 1. And then the output values of that is going to be channel I, close it, and that's going to be, say, kill statement and kill state max. Create both of those. And it's probably going to be fairly high values, so let's make it 16 and 20. And then we can just say if at state or at in state equal to or greater than seed then at dead equals 1, and I get an error because I did this the wrong way around. It's greater than or equal to. Let's see if that works. And we can see the points are now dying. Kind of stuck at the beginning, but they're definitely dying. So let's create 30 and 25. We get some sort of a movement there. Okay, so all the basic elements are working, and then what I did as an extra to make it look a bit more interesting, but definitely not what the tutorial is about, was I added a pop fluid right at the end. And with this I'm setting I can set the viscosity value fairly high, maybe give it a couple of extra constraint iterations and set the constraint stiffness really high. Particle separation is probably too big as well. Let's make it 0.02. If I hit play on that, get this liquidy look, some surface tensiony effects happening there. Okay, so that's pretty cool. The only thing that's probably missing is dialing in some values. But that's everything that we need for the actual setup. Okay, and with all the elements in place, I made a couple of adjustments to some of the settings to get us into a better place and get the effect looking like this. I'm kind of happy with it in this state. It's probably not perfect. Some of the stuff in the emission area where it's shooting out just before it hits might be looking a little bit steppy, a little bit too uniform. Probably some room for breaking it up the emission there a bit, but I'm liking the shapes that I'm getting from the actual dome as it's shooting out. And let me show you what I've adjusted. So in the setup itself, just going to the sourcing. While I was setting up, I never set the shield force higher. So I set the minimum distance to 0.8 and the max to 2.5. And I think I left this at like 2 and 1. That's why we weren't getting a lot of force. So if I bump this up to 35 and 10, it's a lot stronger. Then I've just smoothed out this vector value. Like, it's not that big of a deal, but yeah, let me just show you what all of them do. I'm going to turn off the fluid for now because it runs quicker. But I've smoothed out this vector value, and then I've smoothed out this VDB a little bit as well. And I've turned off trimming to keep our interior voxels, because if you keep that on, you're going to have some points going through the collision again. And inside the DOP network, we've got a stronger field force. I've just boosted the radius up a bit so it picks up the force a little bit quicker. And then also I've added, once it's in this state, I've increased the prop drag to 0.2, so I get a little bit more drag on those points. and I've added a pop force just to add some curl noise, amplitude of 10, swirl size of 0.3, and a pulse length of 0.5. And just without the pop fluid, it looks something like this. So you can see that looks pretty cool as well. We now get points spreading fairly evenly, shooting out a little bit of a hole in the middle if you look carefully. That's kind of where it's pushing the points away. And this on its own is probably already a cool effect. If I go up and turn off both of the smoothing steps and the curl noise, and play this again, you'll see it's a little bit steppy, and the pop fluid will hide a lot of that. But what we need is just a little bit more breakup, and I'm doing this to get some more accurate, smoother interpolating vectors coming in and a smoother collision coming in. You can actually see it if you look carefully on the VDB before the smooth and after the smooth. It's a much more accurate circular shape, and the force adds a bit of breakup. And then I'm adding the pop fluid on top to get the new shapes. And I'll be honest, for the most part of the pop fluid, I'm kind of guessing values to see what I kind of get. So I get a separation of 0.2, which is I think a little bigger than I had before. I've increased the iterations, I've upped the stiffness, I've upped the tensile radius, so that means they're pushing the radius where the points fully push each other away is a bit bigger. And but I reduced the tensile strength. That's how strongly it repels each other. And then I've upped the viscosity all the way to 1. And I think this is probably even different values to the initial test that I did. And I just kind of mess around with these values until I get something I like. And yeah, that's it for this tutorial. I hope you enjoyed it, found it useful. See you next time. If you want to see more videos like this, go check out my Patreon page at patreon.com/Zabrand, or follow me on Vimeo. And if you're not a Patreon yet, please consider subscribing and gaining access to some Patreon only content. And as always, to all my patrons, thank you very much. I can't do this without you guys.